Good day. Welcome to the Turris Academy number 9. And today we are going to be talking about migration from Turris OS 3.x to the latest version that is 5.2. So actually you might want to just know from the start for if you are a user how to get this migration, how to get from this old version of Turris OS to the newest one. For you, this is this slide. Basically, you are most likely interested in the documentation. You want to read it. You want to know about what are the limitations, what are the changes you might want to expect. Before you click on the package list, you see on the picture. Basically, from you, it's only about enabling this package list, clicking save, and everything should be from there automatic and migration should be performed. Of course, you have to expect that it's going to take some time and it's going to, of course, not be instant and there is a possibility that not everything you had is going to work. Automatic migration is basically around the corner right now. For Omnia, with serial numbers 0, ending with 0, this is going to be tomorrow. And this also going to include old Turris 1.0 and 1.1 routers, but only if they are running Btrfs. Those routers were only in Czech Republic. So some of you might get it automatically tomorrow. Some of you can already migrate by enabling the package list, or basically everyone who wants can do that already. So what are the changes? What you are going to get? This might sound initially a little bit negative because I'm going to be talking about stuff you are going to be might possibly missing. But I want to put it this way because basically these are the changes we had to do to get the newest version, and mostly they are about obsolescence of old stuff. And everything new is basic that are you going to get with the new version is for you to discover. So let's go through this list. Basically, the initial thing that you should know is that mobile application is obsolete, and with that, API tokens that were required for it, as well as server-side backups, Majordomo, and home automation packages like Domotic and Home Assistant. They are no longer maintained by us, by the Turris team, and they are no longer essentially in some cases possible to install even, and in some cases you have to opt-in install it as the external package. The another one that probably some of you are going to not like is that the cups is going to be missing. So the print server, you have only option to propagate the connected printer using the P9010 protocol, and cups right now is not available. It's basically because we had to maintain it. It wasn't easy, and OpenWRT, which we are based on, unfortunately does not support cups, so it was dropped. There are other changes with package lists that were no longer that are no longer present in the new version, and you have to install those packages manually. And the one very important change is complete rework of switch configuration. For the advanced users, if you are configuring network setup with some special configuration in the switch, you should know that the configuration completely changes. We are no longer using switch config. There is going to be in-kernel solution DSA, and you have to get used to it basically. But it's even for, I think, a better experience. And the last change you probably most likely won't even notice if you are not going to look to your data you collect with our attack prevention system. We collect the old project.turris.cz. this website is only for the old versions of this research project, and new version is only for Sentinel View. We call it Sentinel now, and the backend, basically the uh, attack prevention software, is completely rewritten, completely new, and this is one of the major changes there are from the previous version. So now to the core, why actually we need to migrate? Why we need to do some special steps? Why we can just do the update as the normal? Well, there were a huge changes between year 2016 and 2018. There were OpenWRT at the year 2016. Then basically the whole community OpenWRT fell apart, and the project lead was created. Then lead was merged with OpenWRT, and OpenWRT was here again in 2018. So this was a time of turmoil in the OpenWRT project, and that mostly meant that a lot of changes happened, and most notably incompatible changes. So it's not just simple update. You really have to do the complete migration and somehow fix all those changes and cover those cases. Just to show you, the Turris OS 3.x version was built on OpenWRT to 15.5. This was from 2015. Well, actually, the latest merge was from January 2016, but basically, this is version from 2015 of OpenWRT. And the next version, Turris OS 4.0, was on OpenWRT 18.6. That means pretty much 2018, almost 2019. So there is a huge leap, and this leap means that there were huge changes in configuration. We even changed the libc, so basic component of the almost all software that is run on the router was changed for on Turris 1.0 and 1.1. There were original UC libc, and now we are using muscle, the same libc as is on Omnia. This creates a lot of issues, of course, during the migration. Another change was basically that we took a liberty to restructure our internal stuff. So there are the repositories you might been used to from Turris OS 3.x are in different places. They are structured differently. So all the packages the system pulls are basically in different places, and we have to cover somehow that. And not even that we move the packages, also upstream and us, we changed a lot of the packages, we removed a lot of packages, added a lot of packages. So this of course means that there were a removal a lot of functionalities, but of course additional a lot of functionalities. So let's look at the configuration. So in the configuration, as I already told you, there were a switch from from switch config to DSA, and we have to cover that. So basically, this list is about all the migration steps in the configuration we have to do, and actually, the configuration migration was the easy part, and the rest of the presentation is about the hard part, that is to update the packages and get it from the working state in Turris OS 3.x to the working state in the latest version of Turris OS, and not break some, not halt something in the sometimes in the middle where there might be broken stuff, and user would end up with basically bricked router. In the configuration, we switched from the switch config to DSA. So every configuration that was about networking had to be migrated for that reason. Another change is that in Omnia, originally SFP port, you could plug in the module in runtime, and it was automatically registered and used. Unfortunately, this is not right now possible because with new version we switched to handling this in the kernel, which does not support it. But the advantage is that some of the modules that were originally not working are now supported because they are supported in the upstream kernel, which we are now using. Another change is just minor one, but it was also in pain in the ass a little bit. Was the change of Wi-Fi cards identifier. Basically, we had to change how Wi-Fi cards are identified in the configuration and just switch it for the new identifier, and that's it. There are changes in the SSH, and one huge change is that we updated LXC from version 1 to version 3, and actually in the current version we have version 4. You can see that those are major versions, and if you know something about LXC, from version 1 to version 2, they pretty much reworked the configuration, so especially the network configuration, so we have to somehow cover that as well, and we try to do that. And of course there is a switch from Ukulele to Sentinel, which in the end of course wasn't that hard because it's our software. There were a lot of changes in secondary software that I'm not listing here, but those are not directly addressed by us. They are either directly addressed by OpenWRT community, or unfortunately they are left alone because their maintainers did not cover them. So now to something more in depth. Let's see how actually this works, how this configuration migration would look like. For example, here it is the case with wireless. So we have some package that is named TOS324, where we have migration scripts. Intentionally, we placed it in the newest version of Turris OS, not the old one, because in the future we don't have to release that older version and still migrate to the newer version of the configuration. And here is just the simple script that does that Wi-Fi identifier change, just to illustrate how such configuration changes looks like. So let's now step aside from the configuration. As I said, it wasn't that easy, but it was the easiest part of the whole migration. Let's consider now how the migration itself is executed. One of the options is to do offline upgrade. Well, that's pretty much what everyone does. What does it mean is that you download the new system, image of the new system, you just flash it, migrate all the previous configuration, just add it to that image, process it through those scripts I previously showed you and I was talking about, and then you perform reboot. That's it. You end up with a new system with somewhat migrated old configuration. This has few disadvantages, especially that the user most likely is going to lose files or software, but in the end that is going to happen with alternative upgrade methods as well. The advantage of this is that it is really simple. Really, it's why everyone is doing it. So you just do few steps, refresh it, and it's done. It's even pretty fast. And thanks to Btrfs, for us it's even atomic. That means that if that process is not finished and you reboot the router or the router loses power, it doesn't matter. It's all right. But why that's not possible is this little piece of the code that is practically in every package that is free in OpenWRT. This piece of the code checks if the current installation route is actually something specific or if it's not specified. When it's not specified, it is the current route. So basically what this tells, that package migration is executed only if we are running on the online system, if we are running on the system that we are running right now. We can't do offline upgrade we can just take the file system, update all the packages, because none of the migration script would run. None of that would work. So we would either have to take all of those migration scripts and rework them to work also in the offline mode, or we just simply can't do the offline mode. So in the end, we ended up with upgrade in runtime. So now let's look at some theory about the updater and updates and how it actually works in Turris, because of course this is a little bit a look in the behind the curtain. It's really fast, but it's kind of a deep dive to the updates. So you have to know something about how packages in Turris are maintained and how they are updated. Basically, software we use it for it is updater, and it uses Lua directives that are downloaded from our server, verified of course, and evaluated in the router. And from these directives, we get basically three types of information. We get source for the packages, repositories. We get request for packages. Those are basically request for having something in the system. Here, that is represented by install command that request package updater ng and updater supervisor, where there are special options possible. Here it says that those packages are requested critically. That means that update won't succeed if those packages can't be obtained or updated. And then there are some additional information for package. So for example here for updater ng, there is a possibility to specify replan. I'm going to get to that a little bit later. There are other possibilities such as requesting that something should not be installed, switching the mode, but for us right now, this is almost everything we need. Let's just look to that last one, the specific modification of the package parameters. We have a selection in updater. We have a selection of parameters we can use to tweak the behavior of the packages, and this is the list of them. Virtual is that there is no binary package. Basically, it's just the name, metadata, meta information, and nothing underneath. For us, for example, you can imagine it that if some package wants some other package and that package doesn't exist, and you mark it as virtual, then it's all right, because updater is not going to look for the binary package for it, so it won't find out that there is no such package. Basically, this is the option to hide that you don't have some package as the dependency or as generically any package you could get, you couldn't get. Then we have an option to specify additional dependencies. So basically, if one package needs some other software, then he adds it to the dependencies. If we want to add additional packages to that, we can do that. And another one is reboot. Basically, it does what it says. It performs reboot. You can specify either delayed or finished. If you specify delayed, this is basically what you experienced pretty much most of the time, because this is how you get the notification that the reboot has to be performed because some packages were updated, mostly because kernel was updated. And another one that is going to be important for us right now is unconditional reboot at finish of the update. So basically, this is the case when update finishes and we do reboot without asking user and just reboot right now. Another one is replan. This is a little bit special because it basically is only for the updater, and what it does is basically it forces the updater to terminate and run again. Why we need this is because some packages are going to install files that updater runs and modifies its behavior, and we want to immediately apply those changes. So we terminate the updater and immediately run it again, and thus read those changes. We can do it either at the finish of the update, so at the end of the update, we do this replan, or we can do it immediately after some package is installed, which is again important for this case, but most of the time irrelevant. And then we have something that pretty much works pretty easily, and on the next slide I'm going to tell you that that's how it is, and those are update change and update change deep. Basically, if some package depends on some other package, and that other package changes, we can say that that other package changes ABI, and thus every package that depends on it would be reinstalled. There is a special need for it for binary interface. That's why it is called ABI. But most of the, the times it is just needed for example, libc and packages like that, where we know that if we update it from one version to another without reinstalling the rest of the software that requires the dependency on it, we would end up with broken system. So that's why these options are there. And for the completeness, there is also order before, order after, but let's not talk about them because they never worked. So, first iteration. This is how, from current understanding, I would start to implement it, but of course, I out of the box know that this won't work. So we have a TOS 324 package in Turris OS 3.x. This is the first package we install, and this package just only includes in the updater the following code. It pulls some script from our server. It's special script that we placed there, and that's it. This is intentional because this way we can update it on our server without ever releasing the new Turris OS 3.x version if we need to change something. We only have to release the version 5 point something, or in the future 6, and so on. On the server, initially, let's say there is only just one multiple lines, but one statement in that migrate 3.x Lua, and that's just declaration that there is a repository somewhere else with a higher priority. The default priority is 50, which means packages from new locations are going to be preferred, and theoretically this should result in the migration. This should install new packages from new location, the newer version, so update whole system and everything would be awesome. Of course, then this presentation wouldn't be here. So we have to go to the second iteration, because actually to do that we need the newer version of updater. Why? Because those packages in the new repository look differently, a little bit, slightly differently, but we need just the new version updater to understand them. So we, as the first option, do that. Yes, we point to that repository, but we use it only to update updater as the first option, and few additional packages. First use here, you can see that we need to do replan for the package, immediate replan. What does it mean is that once we update updater, it is terminated and the new version comes alive, and thus we can continue the update and can perform the update from those new awesome repositories. Unfortunately, this is of course not automatically possible, because, for example, there are some missing dependencies. So we had to add them. You can see here that there is a libgcc busybox edit to the dependencies, and one special one, tost324 early, which contains the migration script just for update configuration. So it's part of the initial start where I was talking about the configuration migration, where there are some scripts. One of them is in this special package. So this should result in the update, and the next execution with the new updater is going to pull all those new awesome packages. It is going to reinstall everything that depends on libc thanks to this last line, and everything is awesome. Unfortunately not, because updater tells us welcome to hell. Well, it basically has the special soft part of it that tries to prevent any file collisions. Those are when one package provides some file and another package, either new or both of them can be newly wanted to be installed, provide the same file. The result is, of course, that they would share that file. And from updater point of view, which one of those contents is right, from the one package or from the other. Here is an example. We have two cron providers. Basically, don't care what is cron if you don't know, but it provides special file that is binary cron. And in the system, there is a package that is called Vixicron, and we basically removed the Vixicron in the new version of Turris OS and replaced it with Crony, which is alternative for it. They both provide the file, the binary cron. And thanks to the replan, how it works, basically updater is convinced that you are trying to install both of those packages side by side, and thus create this collision in that specific file, and it basically breaks and tells you, no, I won't do it. So the solution is simple. Let's just say that either one of them does not exist, is binary. For example, here we do it for Crony. Unfortunately, updater has another thing in the mind, because actually it tries to check in that specific version if there is actually no binary package for that specific virtual package. In the end, we try to mask that Crony exists and instant to prevent that collision, but he doesn't like that either. So right now we are basically at the stalemate, and what to do next. So let's follow up with a little bit more of the theory about updater. Let's talk about how updater tries to sort packages before it installs them. Basically, there is a set of rules that it follows, and the first and most important rule is that all the packages that are dependent on some subsequent packages are ordered before it. So this is just that you have to install dependency before the package it depends on. The second rule is that conflicts should be removed before the package that they are conflicting it is installed. This is basically outside the scope of this, and we are not going to use it here. The third is that critical packages are preferred. So if package is requested critically, then it gets bumped up and installed earlier. Then priority is used. So higher priority means earlier installation, and the last one is that we first install all packages and then we remove them all. This, of course, primarily applies only for the new updater, and the older one had these rules little bit same, but sometimes it did not follow them exactly, which created another set of problems I don't want to go into here. But in the end, we have to use these rules, and if I return to the previous slide, we have to convince the updater to not install cron before it tries to remove Vixie cron. So we have to somehow not install that cron with the replan. That's it, because we won't remove packages if we do immediate replan, because we don't do removals at that moment. We only just try to install that one single package that requested the replan. So we go to the third iteration where we take the even earlier package and just try to move it later on. And so this way we first install updater, because that cron is requested by the tost324 early actually. We move it later. This way we basically ensure that the first we update the updater, and then we run everything, including the removal of Vixie cron. Nice. That's one step. Actually, we have to go to the fourth iteration, because now we are able to perform that update. But it takes really long. It really took around a few hours to finish. So what was actually going wrong? Because in the end, it really finished. It really worked out. But it turns out was that there is a bus called ubus in the OpenWRT, and basically everything communicates through it. The issue here was that the init system in OpenWRT uses it to communicate, to get basically information if some service should be restarted or stopped and stuff like that. And this is something that happens pretty much with every package when you update it. It pretty much every package tries to restart its own service. And the new version of ubus stopped communicating with the old one. So there was a server running, or daemon if you want, that was unable to communicate with the client application that was installed at that moment. Basically what is needed is to restart that daemon to get the new version of it. And that means that we have to, at some point in that update, detect this, kill ubusd, and it is automatically restarted again thanks to that init system that OpenWRT provided us with. This is pretty easy. We just in the ubus package add the script. I show you the first one script I am presenting. Just try to call ubus call system info. Doesn't matter what it does, but if it fails, then consider it lost and kill ubus daemon, which refreshes it, and we consider it restarted. But we won't do this all before any other package tries to communicate with that init. So we have to do it right before we do all other packages. How we do it? If you remember the ordering rules, we do it using the replan, because those packages are prioritized and ordered before every other package. So we just say that we do immediate replan. Although we won't install anything new for updater, this allows us to do actually what we want and update ubus as the first package at a specific point. Okay, so now init script should work. Update should be performed pretty much awesomely, but still sometimes the update won't finish and end up in pretty much broken state. So what's going on? It turns out that it was ending up on inconsistent, that some package is not available. Basically, that was, for example, if you install caps, that I was at the beginning telling you that unfortunately it is no longer available. The updater just going to break because it does not want to take away caps from you without telling you about it. So it waits for your confirmation in the form of removal of the caps package. But if you remember, we are switching to the new to the new libc. We are updating all the dependencies, which pretty much makes the router completely broken at the point when the updater finds out that you want package it can't provide you with. So what can we do about it? In the end, we implemented completely new feature just because of it. To the updater, we made all the installs optional. What does it mean is that we basically skip this check. That's it. So during the install, it should not break, but at the end, this mode is disabled again, and you're going to get all those messages that some packages are not requested. And this is probably something you are going to encounter if you used your router heavily. And yes, you have to just go and remove those packages even if they are not anymore available in your system. Next step is a little bit step aside. It's just something different that we found out during our process of getting the migration work. Is that local repo, something you might not even notice that there is there, uh, pretty much was able to break the system because it was it was inserting the old packages to the now new system. The reason for it is that basically if you download the binary package not from the repository but directly, or you upload it to the router and install that, then we have to store it somewhere, and local repo does that. Unfortunately, at that point, it is for a long time in that local repo, and it's stored there. Of course, the issue here is that the new version of the updater doesn't work well with the old version of local repo, and that the old packages are going to be broken. Solution is simple. We just removed every single package in the local repo and stored it in the specific location. So if you have some special packages in there, they are not lost. You just have to look in this specific path. And now to do practically end of the migration, seventh iteration. Well, now imagine that we finished all the configuration migration, all the packages updates, everything is finished. But what it turns out happens is that the router looks like a brick. Why? Because all the configuration was migrated for the new version of the kernel. Especially this applies to DSA. So the switch configuration, network configuration now is prepared for the new version of the kernel, but you are running the old one. And to connect to that router, unfortunately, all the configuration is mangled and broken. So you can connect to the router to reboot it, and only option from the user point of view would be to go to that router, press the button, or unplug it and plug it again, which is of course not user friendly. So right now, here it is where we use the reboot. Basically, what we do is that when we install specific package, TOS324, this time it is at the end, this is the newer version of the TOS324 package from the newest Turris OS, we do reboot. So this basically forces the updater to call reboot and the result is that at the end of the migration, your router is going to be unconditionally rebooted, so be prepared for it. And for the 8th iteration, let's not go there. There was a multiple iterations of this, of course, but let's just recapitulate how the update actually looks like, how it actually works, because I'm sure that from those 7 previous iterations, you are most likely lost at what actually happens. So at the first step, we install a specific package that has the script that triggers the migration, points us to the specific script in the new version of Turris OS. And as the second step, we installed the new version updater and install TOS324 erase of the one of those migration scripts is inside that package. Then we have to do that special dance for UBoost. So we upgrade UBoost, wait 2 minutes to detect that UBoost actually does not communicate with us with the new version of the client and kill the UBoost replan and run again. Next, we do installation of actually TOS324 early, where we migrate all the updater settings. Now, from the point of updater, we are running on the new version, but the packages underneath are still old. So we have to, as the step 5, update rest of the system, remove any old packages, basically perform the update itself. And the last step is to do replan, reboot as the completely last step, and after that reboot, what you should see is removal of TOS324 package, which should generate you a notification and migration is complete. This is not completely everything, but mostly. This is all from me, but let's now look at how it actually looks from the end user point of view and partially also how it looks from the developer. So let's now switch to the video. Here you can see the old Forest GUI. Basically what you have to do is to follow to update tab and there to select migrate to Turris OS 5.x and save it. This is going to install the TOS324 package and trigger the migration. I'm switching to terminal where I'm going to tail the system messages to just show you what is going to happen. Basically, we run the updater to install the TOS324 package. Then we update the updater. That's something that right now updater starts to deciding to do. In just a few seconds, you should see that yes, here it is, that it is going to update updater ng, and now it pretty much just going to follow with the update of or doing that update and updating the rest of the steps, doing few different replans, and basically following those steps I recapitulated just a few moments before. Here you can see, for example, that UBoost, and now we are going to wait few minutes just because we are waiting for UBoost to be killed. I don't want to bother you, so let's now switch to your question, if there are any. So the first one is if that updater sounds cool, is anybody else using it? Are all Linux package managers so versatile as customizable? Uh, well, I'm happy to hear that updater sounds cool to you. Unfortunately, not anyone else is using it right now. Let's say to the it is really in the development still, and most of the distribution are not so easy to switch to some new package manager. But most of the Linux package managers are not that versatile. They are doing the same steps, but they are actually doing it differently. They are not controlled by some specific script most of the time. They are most of the time just following some predefined rules on the packages, and this of course introduces that not everything is possible, and sometimes upgrades are really hard to do. Advantage of the updater is that we can prepare those hacks to those scripts, and thus allow stuff like the migration I just presented. Uh, this all sounds like an awful lot of work. How much of it you do you think you can reuse then when Turris OS 6 will be out? Basically, anything that touches Updater, because we improved Updater but from this, and we can reuse everything we knew from it and use that for the updates and migrations from the to the new version and make it even smoother in the future. Unfortunately, of course, those migration scripts and special hacks, they are of course only for migration from Turris OS 3.x. For sure, there are going to be new hacks, new migration scripts for Turris OS 6.0 and 7.0 and so on. Thank you for the questions. That's pretty much it, probably, because no other question arrived. So thank you very much for attending this Turris Academy, and hopefully see you next time.